This video is on how to draw Lewis dot structures for molecules. For this task in class, you're going to need a periodic table, and you're also going to want to be able to refer to your rules for drawing Lewis dot structures for molecules. And depending on how good you are at math, you may or may not want a calculator as well. A reminder before we get started is on how to find the number of valence electrons for each of the atoms on the periodic table. Dependent on what column they're in, that can give us information on how many valence electrons they will have. For instance, lithium is in group 1 and it has 1 valence electron. Magnesium's in group 2, it has 2 valence electrons. For chlorine, all the way over here, a halogen, chlorine is in group 17 or 7A. It has 7 valence electrons. Nitrogen is in group 15 or 5A. It has 5 valence electrons. You will need to be able to quickly go through that in order to draw the Lewis dot structures for various molecules. So the first thing we are going to start with is NH3. Now in our rules, our first step is that we want to determine the total number of valence electrons, and we're going to put these electrons in a grab bag. So in this compound, we have 1 nitrogen. Each nitrogen has 5 valence electrons, and we're going to add that to 3 hydrogens, and each hydrogen has 1 valence electron. That gives us a total of 8 valence electrons that need to be shown in our structure. The next step in our rules is that we need to determine the central atom. The central atom is whatever element is present in the least, or if carbon is present, it will be carbon. The element that's present in the least in this compound is nitrogen. So nitrogen is going to be our central atom. The next step is to arrange the atoms around the central atom. So since all we have left is hydrogen, we have 3 hydrogens that we are going to arrange with single bonds around the central atom. Recall that each bond represents 2 electrons from our grab bag. So currently on this structure, we have 2, 4, 6 electrons being shown. And since there are 8 electrons that must be shown in the grab bag, we have 2 electrons left to distribute. It says in step 5 that we need to fill in extra electrons to the outside atoms first, completing their octets, and any remaining electrons go in or on the central atom. So for NH3, hydrogens are the only atom on the periodic table that are happy with just 2 electrons. So you will never be adding electrons to hydrogen. It is happy or stable with 2 electrons. So because each of these hydrogens have a bond going to it, it's happy. So the last 2 electrons from our grab bag are just going to go straight on to our central atom. You always want to double check at the end of your Lewis dot structure that everything is happy and stable. So each hydrogen here has a single bond going to it, so those hydrogens are happy, and then this nitrogen has 2, 4, 6, 8 electrons on it. So the nitrogen's happy as well, and this is our Lewis dot structure for NH3. The next one that we are going to do is CH3I. So I've come up with a quicker way of looking at the rules here. So our first step is grab bag electrons. And so we need our periodic table, and we're going to count up the electrons in this molecule. So currently we have 1 carbon. And if we look to our periodic table, each carbon, because it's in group 14, has 4 valence electrons. We add that to 3 hydrogens. hydrogens in the first column, so each one has one valence electron. And then lastly, we have an iodine, and there's only one of them, so I'm going to write a 1 here. And each iodine is in group 17, so it has 7 valence electrons. So that gives us a total of 4 plus 3 plus 7, and that gives us 14 total electrons in our grab bag. The next step is to determine the central atom. So again, the central atom is the element that is present in the least. We have 2 of them here, but if carbon is present, then it is carbon. So carbon is present. Carbon's our central atom, and we're going to distribute the rest of the atoms around it. We have 3 hydrogens and 1 iodine. Now we want to make sure everything's happy. We need to fill their octets, and all the atoms on the periodic table need 8 electrons in order to be happy, except for hydrogen. Again, hydrogen is happy with 2 electrons, which is 1 single bond coming off of it. So if we take a look at our structure right now, these hydrogens are happy. They each have 2 electrons going to it. This carbon is happy. It has 2, 4, 6, 8 electrons going to it. So we have this lovely little iodine here. This iodine only has 2 electrons, but it needs 8. So what we're going to do is we're going to use up the electrons in our grab bag, and we're going to add to the iodine until we have no more electrons left. Currently in the structure, we have 2, 4, 6, 8. So here's 10, 12, and 14. Now that also, and that takes care of all the electrons in our grab bag, and that also ends up making iodine happy. Iodine has 2, 4, 6, and 8 electrons. So this molecule is done. Now sometimes students get really concerned about where the iodine is. It does not matter to me what side you put your iodine versus your hydrogens on, as long as your iodine has the correct number of unshared pairs on it. The next molecule that we're going to do is CH2O. And our first step are those grab bag electrons. So from carbon, we're going to get 4 electrons. From hydrogen, since there are 2 of them, I'm just going to add the hydrogens together. So we're going to get 2 electrons, and then from each oxygen, we get 6 electrons. That gives us a total of 12 valence electrons for this structure. The next step is to determine the central atom. Carbon is present, so carbon's the central atom. And we have 2 hydrogens coming off of it and an oxygen. The next thing we need to do is we want to determine how many electrons are in our skeleton structure. Currently there are 2, 4, 6 electrons, but there are 12 electrons in our grab bag. So we're going to add to the outside atoms first, making them happy, and then any extras we put on the central atom. So our hydrogens are already happy because they have single bonds, and our skeleton structure has 2, 4, 6 electrons, so I'm going to add to oxygen until it's happy or until we get to 12, whichever happens first. So here we have 2, 4, 6, 8, 10, and 12. So we have no more electrons left in our grab bag, so now we just need to make sure that every atom in this structure is happy or has a stable octet with 8 electrons. So the hydrogens are happy because they have a single bond. Our oxygen is happy. It has 2, 4, 6, 8 electrons. Our carbon, it has 2, 4, 6. Carbon needs 2 more electrons. So when this happens, when you have a happy atom with unshared pairs on it next to an unhappy atom, you can take away an unshared pair and make it share. And that's exactly what we will do here. So this oxygen now still has 2, 4, 6, 8. The carbon now has 2, 4, 6, 8. The hydrogens are still happy. And at the very end, we just want to double check that our structure only has 12 valence electrons on it. So here we have 2, 4, 6, 8, 10, 12. And so this structure is all done. The last example I'm going to go through is a carbonate, which is a polyatomic ion, so it has a charge. And our first step is to determine our number of electrons in our grab bag. So from carbon, we get 4. And here we have 3 oxygens. Each oxygen has 6 valence electrons. And then lastly, this -2 charge. What that means is that there's 2 extra negatives in this structure. So we need to add those 2 electrons to our grab bag of electrons. So now this gives us a total of 24 valence electrons in our grab bag. The next step is to determine the central atom, and for this one, carbon is present, so it's going to be carbon, and we're going to distribute the oxygens around the carbon. Here we have 6 valence electrons now, 2, 4, 6, shown in our skeleton structure. We're going to add electrons to the outside atoms first, filling their octets, and then any extra from our grab bag will go on the central atom. So here we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. All right, so we've used all the electrons in our grab bag. All the oxygens are happy. They each have 8 valence electrons, but our central carbon is not happy. Our central carbon currently has 2, 4, 6. So just like the last example, we are just going to take an unshared pair from one of the oxygens. It does not matter which one. I will just use the one on the left-hand side. So I'm going to take away an unshared pair, and then from that same atom, I create a double bond. So this oxygen now still has 2, 4, 6, 8, and the carbon is happy with 2, 4, 6, 8. The very last thing is because it's charged, technically we do have to put brackets around structures that have a charge, and then we put the charge after it. Where this is the technical thing we have to do, I'm not as concerned with making sure you have the brackets as long as your structure is correct.